Okay, let's dive into this. Welcome to today's explainer. We are opening up the Economist Toolkit. Have you ever stopped and wondered how math acts as this incredibly powerful translation tool for decoding messy, totally unpredictable human behavior? Well, today, we're going to demystify exactly how numbers tell the hidden story of our daily lives.
Seriously, think about it. How do we actually take chaotic, everyday decisions, like say you deciding whether or not to buy a $4 cup of coffee this morning, and transform that into clear, actionable economic insights? I mean, it almost seems impossible, right? We humans are emotional, we're spontaneous, we're complex, yet economists have actually figured out a brilliant way to map out all these human choices using mathematics.
So here's our roadmap for the explainer today. We'll start by translating human behavior, then cover the basic equations and graphs. After that, we're going to look at optimizing with calculus, making sense of massive data sets, and then exploring finance and game theory. Finally, we'll wrap the whole thing up with the true power of mathematical precision.
All right, let's kick things off with Section 1, Translating Human Behavior.
Because look, before we can just start plugging numbers into a calculator or drawing up complex models, we have to deeply understand the motives driving the players in our economy. And the contrast here is absolutely fascinating. As consumers, our mathematical goal is to maximize satisfaction, or, what economists like to call utility. Basically, we want the absolute most happiness for our buck. Businesses, on the other hand, well, they're driven by a fundamentally different primary motive, maximizing profit. And if you zoom out even farther, you've got governments using these exact same mathematical principles to balance massive broad goals. Things like economic growth, keeping inflation in check, and managing unemployment.
Moving right along to Section 2, the basics, equations and graphs. So let's explore how economists make these totally abstract human motives beautifully and practically visible. Now, the demand equation might look like some daunting, scary algebra right off the bat, but trust me, this isn't just dry math. This is the literal mathematical representation of you standing at the coffee shop trying to maximize your satisfaction. See that negative sign in the formula? It perfectly captures human nature. When the price of that coffee rises, your demand for it usually falls. It's literally human behavior written in code.
And when we plot these equations onto a graph, oh man, things really come alive. Combine that downward-sloping demand line with an upward-sloping supply line, and the exact point where those two cross, that's the market's equilibrium price. By making these concepts visual, economists can effortlessly track massive economy-wide trends. We're talking things like inflation, unemployment, global trade flows, taxes, and interest rates. And to think, it all starts with just those intersecting lines.
Now for Section 3, Optimizing with Calculus.
Basic algebra is great for static situations, sure. But what happens when a business needs to find the razor-sharp peak of their potential profit in a constantly changing market? Well, calculus swoops in to save the day. To absolutely maximize profit, you follow a very logical step-by-step process. First, calculate total revenue. Next, calculate total costs. Then, find the profit by just subtracting the two. But here is the real magic trick: taking the derivative of that profit function and finding exactly where it equals zero. In the wild world of calculus, that 0 point pinpoints the absolute highest peak of the profit curve. It's brilliant.
And this brilliantly illustrates how calculus isn't just some abstract theory you might have slept through back in university. No, it's a direct, highly practical method to answer urgent, high-stakes business questions. Want to know the absolute best price to charge so you don't scare off your customers but you still make money? Use derivatives. Need to figure out the maximum profit level, or maybe analyze how incredibly fast your supply costs are rising? You rely on the calculus of change.
Let's jump to Section 4, Making Sense of Data.
So, we've optimized individual choices and single businesses. But how do we analyze the massive, swirling oceans of data generated globally every single second? Enter econometrics. It is this incredibly powerful combination of economics and statistics used to deeply analyze information and predict upcoming trends. Because let's face it, economics depends so heavily on real-world data. We're tracking wages, GDP, consumer spending, stock market fluctuations, you name it. Economists need incredibly rigorous statistical tools to actually evaluate all of this without getting completely lost in the noise.
Econometrics tries to solve some really massive real-world mysteries. Like, does raising interest rates actually reduce inflation? Does more education strictly equal a higher income? Will unemployment rise next year? You see, these aren't just theoretical musings for academics. The answers dictate national policy and directly affect millions of lives. Proving these connections with statistical certainty, that is absolutely essential for predicting the future.
All right, Section 5, Finance and Game Theory.
This is where we get into some of the most dynamic, fast-paced tools in the whole toolkit. Modern finance is, quite frankly, extremely mathematical. Take the compound interest formula, for example. Banks and everyday investors rely heavily on models exactly like this to accurately price stocks and bonds, to calculate long-term risk, predict returns. I mean, they use it to manage everything from your monthly mortgage to your retirement pension. Without these models, the global financial world would literally grind to a halt. No joke.
But what happens when your decisions depend entirely on what someone else is doing? Well, that's game theory. It's utilized in fierce business competition, high-stakes auctions, political campaigns, international trade agreements, and yes, even deep military strategy. When people are making strategic choices based on the anticipated moves of others, economists step right in. They use probability, razor-sharp logic, and complex matrices to completely decode the chaos and predict the winning outcome.
And finally, Section 6, the power of precision.
So, the crucial point here is, why do we go to all this trouble to wrap simple human behavior in complex equations and mathematical theories? Simple, because without it, economics entirely loses its predictive power. Math seamlessly scales our understanding. We start at the basic level with simple percentages and supply and demand graphs. Then we move up to the university level with calculus and statistics. And today, at the absolute most advanced levels, economists are using differential equations, complex optimization theory, and even machine learning. They use this to test theories and measure relationships across datasets that are literally just too large for the human mind to comprehend alone.
Let's bring our journey right back down to earth for a second, back to that coffee shop from the very beginning. If the owner just randomly decides to raise prices, it's a huge risk based purely on a gut feeling. But when we apply our mathematical toolkit, we can calculate the exact expected drop in demand, we can predict specific revenue changes, and we can pinpoint the absolutely optimal pricing strategy. We completely transform a simple, risky guess into a highly calculated, optimized, and profitable strategy. Which leaves us with this final, kind of provocative thought to ponder. Without the precision of mathematics, are we all just guessing at how the world works? Math isn't just about crunching numbers on a calculator. It really is the fundamental language we must use to test theories, understand complex realities, and truly decode human behavior. Thank you so much for diving into today's explainer with me. Keep questioning, keep learning, and I'll see you next time.